Hello YouTube. In this video we're going to be just working through an application problem that utilizes the law of sines to help us do some metrics or some measurement. Doing this especially though, however, because a lot of people have difficulty understanding bearings and how to use bearings to measure direction when it comes to navigation. So let's take a look at what we have. It says the course for a boat race starts at point A as in the figure to the right. So you see up here on the right, I've already drawn in the figure, and lucky us, we actually do have the figure. So we say point A. It says it proceeds in the direction of south 52 degrees west to point B. So you see point B over here, and you can also see my 52 degrees that I've already drawn in. But recall then, when we talk about bearings, we typically either give north or south first and then talk about how many degrees will deviate either to the west or to the east. So in this case, we'd said, if you look at my little compass I drew up here, we say south. It's like saying we started south. Well, let's change colors here. Start south and deviate 52 degrees up to the west, okay, which is this measurement that you see over here. So yeah, moving right along, we say south 52 degrees west to point B, then in the direction of south 40 degrees east to point C. So you'll notice here at point B, I've dropped in this dotted line here, and actually what this is just some north-south dotted lines. So when you use bearings, you just go ahead and insert one of those dotted lines in. It's going to be a big help because we're going to borrow from our knowledge of parallel lines and transversals that we know from geometry. We say it finally returns to point A from point C. It says point C lies 8 kilometers directly, or kilometers, excuse me, directly to the south of point A. It says approximate the total distance of the race course. So one thing we know right off the bat is this: AC, this segment AC or a line through AC, is north-south, okay, and that's important. And the reason why is because it means it's parallel to this line out here on the left side that's passing through B that's north-south. So what we'd like to do is find the total distance around the race course. That means if we're using the law of sines here, it means we need to find lowercase c, we need to find lowercase a. We have a triangle, okay. So in terms of using the law of sines, it means that we're going to need to know some angle-side pairs. Well, what do you mean by angle-side pair? Well, what we mean is this: we need to know both an angle and the side opposite. So for example, we say angle A is 52 degrees, but we certainly have no idea what lowercase side A is. That's not an angle side pair. And then we have lowercase c and its opposite, some angle C. We do not know its angle yet, so we don't have an angle side pair there. And we have uppercase B is opposite, lowercase b is 8, but we don't know uppercase b. In this, in other words, we don't know an angle and also know the side opposite. So it's hard to use the law of sines if this is the case. So here's the trick on problems like this. We say, well, when using bearings, we have a lot of north-south lines running through things and then talking about how far east or west to deviate from north or south. In this case, what we can say, though, is this line that I passed through this point B here is parallel to this line that goes through AC. And if that's the case, then we'd say this angle here, this 40-degree angle, must be the same thing as this angle inside here, this BCA. Must also be 40 degrees. And this is very true because we say that these are alternating interior angles for our parallel lines. That is, if you had two parallel lines and a transversal that were to slice them in half, we'd say this angle here would be the same thing as this angle here, and this angle here would be the same thing as this angle here. So we say 40 degrees, and this is convenient because now we know two angles in our not right triangle, but in our triangle. That means we can determine the third. So 52 and 40 sum to 92. That means that this remaining angle over here is 88 degrees. So now if it's helpful, I mean, we could re-sketch the situation here. We say we know this is 40 degrees, we know that this is 52 degrees, and we know that this is 88 degrees. We also know that this is 8 kilometers, and we're calling this A, B, C. So this is lowercase b. We don't know lowercase a, we don't know lowercase c. So now we're going to use the law of sines to set this up. We do have an angle side pair. As a matter of fact, we know that the angle B is 88 degrees. We also know that its side length opposite is 8 kilometers. So if we're going to say, let's go ahead and say solve for the bigger of the two sides. This is what I always say, go big or go home. Let's solve for side length A. And since we're solving for a side length, we'll put that on the top of our ratio. So we say A over sine of A. Now we know the sine of its angle. We say it's the sine of 52 degrees. This is the same thing as lowercase b, which is 8 kilometers, over the sine of b, which is the sine of 88 degrees. So now solving this for a, we can take both sides of this equation, or this proportion, times the sine of 52 degrees. Oops. And what we turn out, sine of 52 degrees, is that A is equal to 8 over sine of 88 degrees, all of that times the sine of 52. And we'll go a little bit quicker on this next one here. We say that's A, we'll find it in a minute. If we wanted to find, say, lowercase c, we say c over the sine of c, which is the sine of its angle opposite it, is the same thing as 8 over sine of 88. We're just going to use the same side angle pair that we did previously. And so we could say then c is equal to 8 over sine 88. And we'd multiply that first equation there, both sides, by sine of 40, which would cancel it on the left and leave c. So now what we want to do is we want to calculate some figures for this. So we'd say, well, c is approximately, a is approximately. Let's go ahead and calculate these two measurements. So we have 8 over sine 88 in either case, but one is times sine 40. So we say 8 divided by sine of 88 equals times sine 40. So about 5.1-ish. Okay, so that's lowercase c here. It's about 5.1-ish kilometers. Throw a box around it. And we say A is 8 over sine 88 times sine of 52 degrees. So we say 8 divided by sine of 88 times the sine of 52 degrees. We have this side as being about 6.3 or 6.31. I'm going to go with 6.3 for the sake of simplicity. So about 6.3-ish kilometers. So now a few things that I want to say about it. There's a couple things real quick. You should always go ahead and go back over here and maybe like a little bit fill these in, 6.3 km, just to see if it's, you know, a reasonable set of answers. So 5.1 km, and I think this is reasonable. And last but not least, we said, well, we wanted to approximate the distance around the race course, so we need to sum all of these and find the perimeter. So we say 8 plus 6 is 14 plus 5 is 19, and then 19 plus 30 cents plus a dime. If you're in the United States, we say is about 19.4. So we say the perimeter of this race course is approximately 19.4 km. But this is just kind of a brief example, not brief, but a small example of how you would use bearings to set up a navigation type situation and use a law of signs to help you solve for things. So enjoy.